We're going to cover Chapter 4, Reasoning and Triangle Congruence. And we're going to discuss one strategy to problem solving is identify subgoals on page 184 of the textbook. All right, so what will we have to do first, Chatiz?
We have first try to find the angle measurement of the regular polygons.
Right. Okay, so those are examples of subgoals. We'd have to find the angle measures of the octagon and the pentagon. Why, Chatiz?
Because if we find the angle of the regular octagon, we could get the angle of BCA, which then we could find the angle of angle A, the obtuse angle, and then if you can add those and subtract it from 180, we can get P.
All right, I agree with you that you need to find the angle measures, but this is not a straight line. So we couldn't find this. We couldn't find angle ACB, but there's another angle we can find. Anybody? Yeah, Chris, what would you do? Yeah, we can find CAB. So if I find the angle of the pentagon and the angle of the octagon, those two angles, I add them together, then what should this other angle add to that should equal to what?
360.
360. So I can find this angle CAB. All right, so that our subgoals were to find the octagon and the pentagon, to find CAB. What else do I need to do? How can we find angle B? We're not done yet. There's still some stuff we have to figure out. Well, we've got, this is a regular octagon, so these two sides are the same, right? This is a regular pentagon, so these two sides are the same. So that means AB is congruent to AC, and we know this angle. So now, what can we say about these two angles? They're going to be congruent. So we can, what would I do?
We would find the angle measurement of angle CAB, and then we'd subtract that from 180, which would give how much each angle should be, and since they're the same, we can tell that if we divide that by 2, it'll give us each angle.
Right, yeah, so I use Isosceles triangle theorem about the congruent base angles to find the measure of angle C. All right, so that's the idea. You kind of break the problem into different parts. For 1, our objectives are to write statements as conditional statements and to complete proofs using vertical angles and linear pairs. Direct reasoning or deductive reasoning is used to draw a conclusion from a series of statements where the statements are often represented by single letters such as P and Q. Deductive reasoning. Conditional statements are statements of the form if P then Q, often written as P arrow Q. So if you see P arrow Q, that means if P then Q. The statement P is called the hypothesis. Of the conditional, and Q is called the conclusion. So these are called conditional statements. We also call them if-then statements. Here's an example of deductive reasoning. So we have a conditional statement. If it is raining, then the street is wet. It is raining. Then what can I say? Yes?
The street is wet.
Yeah, the street is wet. That's deductive reasoning. Oh, I don't have the. Yeah, I should have said something. I don't have the PowerPoint up here on the screen. Did everybody get the first blank? Everybody have everything filled in up to here? Hypothesis, conclusion, deductive reasoning. Do I need to go back? Okay. All right. So then we've got rewrite each of the following statements in if-then form. The sum of the squares of the legs of a right triangle is equal to the square of the length of the hypotenuse. Somebody tell me how I could write that as an if-then. Any ideas? How could I make that an if-then? Chris?
We square the length of the legs and add them up to then it would equal the square.
You're leaving a part out, though. How about if we do it this way? If we wrote, if a triangle is a right triangle, then the sum of the squares of the lengths of its legs is equal to the square of the length of its hypotenuse. What theorem are we describing? Chatice?
Pythagorean theorem.
Yeah, that's the Pythagorean theorem. So if we have a right triangle, we know about the sum of the square of the legs is equal to the square of the hypotenuse. That's what that if-then is. This one's a little less wordy. All squares are rectangles. We have to add a word to this statement, but what could I make an if-then statement out of this? How could I state it? Let me tell you how to start it. If a polygon, how would I finish that? Chatice.
If a polygon is a square, then it is a rectangle.
Right. If a polygon is a square, then it is a rectangle. Don't forget the then. A lot of times people leave out then. They'll say if a polygon is a square, it is a rectangle. You need to say, for it to be a conditional, you have to have that then part in it. A converse. The converse of if P then Q would be if Q then P. That's the converse. With a converse, you are interchanging the hypothesis and conclusion. So we have some extra stuff here in the notes. I don't have that in the PowerPoint, so we need to do this on the board. Negation. I'll do it on the PowerPoint. Negation is if P, then not Q. That negate, and you negate the conclusion. So if I have if P then Q and I negate it, I say if P not then not Q. Converse, we just covered that. You reverse, you replace the part after the then with what's after the if, and you move the part after the then to after the if. You replace the hypothesis and conclusion. You interchange them. Inverse. An inverse is not if not P, then not Q. You negate both the hypothesis and conclusion. And the contrapositive says now you do the converse of the inverse. Contrapositive is not Q, if not Q, then not P. That's contrapositive. All right, so you have in your notes there 4 related conditional statements. So we have the statement, soccer players are athletes. How could I make that an if-then statement? Somebody else. How could I make that an if-then statement? What would it read as? Then what would that read? Soccer players are athletes. How can I make it if-then?
If a person is a soccer player, then he or she is an athlete.
Yeah, so if you are a soccer player, then you are an athlete. That would be our if-then. Go ahead and, on your own, fill in the converse, inverse, and contrapositive, and then we'll discuss them. So try to do those on your own. All right, so let's see. I'll just call on people. Ahitya, the converse of that.
Okay. If you are an athlete, then you are a soccer player.
Okay, that's correct. If you are an athlete, then you're a soccer player. What would the inverse of it be? Jordan.
If you're not a soccer player, then you are not an athlete.
Yes, if you're not a soccer player, then you're not an athlete. You negate both the hypothesis and conclusion. Contrapositive. Elisa.
If you are not an athlete, then you're not a soccer player.
Yes. If you are not an athlete, then you are not a soccer player. You negate both the hypothesis and conclusion of the if-then. Write the converse of ABCD is if ABCD is a square, then it has 4 right angles. What would the converse of that be, Nina? Chris, help her out. Yeah.
ABC has 4 right angles and it's a square.
Right. Our inverse, converse of that would be if ABCD has 4 right angles, then it is a square. So you don't take everything of the hypothesis. You can leave the if ABCD. Some students think you have to take ABCD and put it after the then as well. It doesn't make as much sense. So you can leave the ABCD, but then the meaning of the hypothesis and conclusion is what's interchanged. Is the converse true? The converse we just wrote, is it true at Shatiz?
It's not necessarily true.
Right, it has to be true in all cases. And it's not, because what could it be?
It could be a rectangle
Right,
or
could
a
be
parallelogram.
could be a rectangle. Right. If a statement and its converse are both true, so if we have if P then Q and if Q then P are both true, the statement can be written as what is called a biconditional. The symbol for biconditional is a P with and Q with an arrow pointing both ways in between them. This is read as P if and only if Q. Biconditional statement. The 3 sides of a triangle are congruent if and only if the 3 angles of the triangle are congruent. So that means it's true both ways. I could have the I could say the if then of this, and I could do the converse, and both would be true. Let's write out the 2 statements. We could write if 3 sides of a triangle are congruent, then 3 angles of the triangle are congruent. The converse of that is if 3 angles of a triangle are congruent, then 3 sides of the triangle are congruent. Questions? Everybody has it. Okay. That's a biconditional. A proof is a convincing mathematical argument. There are 3 types of proofs. Paragraph proof, a statement reason proof, and a flowchart proof. We're going to do most of the proofs we'll do are number 2, statement reason, or 2-column proof is sometimes as it's called in this class. Yeah. Vertical angles. 2 angles formed by intersecting lines that share a vertex but not a common side. A picture of that would be, you can write that down below in your notes. Here, angle 1 and angle 2 are vertical angles. You see they're across from each other. They're formed by lines, but they don't share a side. They just share a vertex. Common misconception about vertical angles. Here's an example of something that is not vertical angles. Vertical angles would not look like this. One and 2 are across from each other, but they are not formed by the same lines, right? They have to be formed by the same lines. So that would 1 and 2 here are not vertical angles. So make sure you understand that. Linear pair. 2 angles that share a common side and whose non-common sides form a line. They share a common side and non-common sides form a line. A linear pair looks like that. Angle 1 and angle 2 form a linear pair in that picture. The linear pairs are always supplementary. That's something else you can say about them. A theorem: if x and y are measures of a pair of vertical angles, then x and y are equal to each other. This is saying that all vertical angles are congruent. X and y are vertical angles, they're going to be congruent to each other. Statement reason proof. we're going to prove, given that intersecting lines L and M with two vertical angles have measures x and y, we're going to prove that x equals y. So we're going to prove that theorem we just talked about. To do that, we are going to add another variable to the picture. We're going to add z to the picture. You can see that's what we on the right side. It's the same intersection. We just have added z, and that's what we're going to use to do our proof. So you can refer to the picture as we go through the proof. X plus z equals 180. How do we know that x plus z equals 180? Shatis.
Because they're a linear pair, and linear pairs have to be supplementary.
Right. That definition we just learned about linear pair. So that would be linear pair. Y plus z is equal to 180. How do I know that? Nina? Yeah, that one's linear pair as well. X plus z equals y plus z. Let's see if anybody else knows what that would be. What would be my reason for that? Okay, Shatis, what were you going to say?
I was going to say x plus z equals y plus z because y plus z is supplementary since it's a linear pair, and same thing for x plus z. And since both angles are supplementary, they both add up to 180.
Yeah, that's the right idea. Anybody else? Okay, what we're using here is, since x plus z and y plus z both equal 180, I can take y plus z and I can replace this 180 with y plus z. We're substituting y plus z for 180, so we would call that substitution. If two things equal the same thing and then they equal each other, that's substitution. That's what we did there. Then what about x equals y? What did I do there? What's that step? What's that? Well, we're proving vertical angles, so you can't use what you're proving in the proof. What do you think, Caitlin? What are we doing when we go from 3 to 4? Rather than say a reason, just tell me what's happening. Anybody, what's happening? Yeah, go ahead, Ben.
Taking z out.
Yeah, we're subtracting z from both sides. That's subtraction, property of equality. So we'd call that subtraction. POE, property of equality. Let's look at this as a paragraph proof. If I were to write this as a paragraph proof, I could do it as follows. I would say, let one of the unmarked angles have a measure z. So that's just what I did to the picture. Then x plus z equals 180 and y plus z equals 180 because they form a linear pair. By substitution, x plus z equals y plus z. Then subtracting z from both sides yields x equals y. And then you put 3 dots. That shows that you've completed the proof. That's an example of a paragraph proof. With a paragraph proof, if you're doing it off of a 2-column proof, don't just repeat the 2-column proof in sentences. You know, like a lot of times people for a paragraph proof, they would just say, they'd write x plus z equals 180 by linear pair. Then x plus z equals 180 by linear pair, or y plus z equals 180 by linear pair, period. And then, you know, they just write a repeat of the paragraph of the 2-column proof. With a paragraph proof, you need to make it flow. So you see they've kind of written it out in a manner that doesn't just repeat a 2-column proof. They give some wording to it. That's what you want to do in a paragraph proof. Another proof here. If 2 angles are congruent and supplementary, then they form, or they are right angles. If 2 angles are congruent and supplementary, then they are right angles. So we're given, what we are given is, in this statement of reason proof, we would be given, let me see what we got here. Yeah, we're given angle A and angle B, where A is congruent to B, and A plus B equals 180. That's taken from the if part, if 2 angles are congruent and supplementary. We're applying it to A and B. Then we're going to prove that A and B both equal 90 degrees. Let's fill in this proof. How do I know that A equals B? A equals B and A is congruent to B is equals and congruent are interchangeable. How do I know that A equals B? From the statement we had. How do I know that? Shatis.
Wait, what were we trying to prove?
We're trying to show, how do I know, how can I justify that statement that A equals B? Angle A equals angle B. How do I know that?
Angle A plus B angle A plus B has to be congruent since it's said in the statement, and since it's something if you do on
Wait a second, you're getting ahead of me.
Okay.
It's simpler than that. How do I know A equals B? Is that?
It's given.
Yeah, it's given. It says it right there in our given. It's given. Usually, 90% of the time, your first statement, the reason is going to be given. You usually list your givens at the top. Now, this next step, same number may be added to both sides. Alright, so let's add angle A to both sides. So angle A plus angle A equals angle B plus angle A. What's my other given statement? Lexi Hoskins.
Angle A plus angle B equals 180 degrees.
Right. Angle A plus angle B equals 180 degrees. That's my other given statement. How do I know that angle A plus angle A equals 180? Let's see. Let's call on Emma. How do I know that? Right, it's substitution. I'm replacing A plus B with A plus A from step 2. I can do that from step 2. So it's substitution. Next step, division property of equality. What would be the result of dividing both sides by the same thing? Shatiz.
Dividing it by 2.
Okay, so what would be the result of that?
What would be the result of that?
Yes.
A equals 90 degrees.
Right, we would have angle A equals 90 degrees. That's one of the things I had to prove. What could I say next? What else could I say? Your last statement's going to be something you had to prove. What else do we need to say? Go ahead, Lily.
Angle B equals 90 degrees.
Angle B equals 90 degrees. And that'd be by what? What would be my reason for that? Julia?
Angle A equals angle B, so substitution.
Yeah, we're substituting B for A, so it'd be substitution. Okay, any questions? Now, I want you to take a minute and rewrite that proof as a paragraph proof. Rewrite that as a paragraph proof. All right, here's an example of what you might have said. you could say let angle A and angle B, angle A equal angle B, and angle A plus angle B equal 180. That's our given part. And then add angle A to both sides of angle A and angle B. That should say of angle A equals. That should say equals. Of angle A equals angle B. By substitution, we have 180 equals angle A plus angle B, which equals angle A equals angle A. Thus, 2 times angle A equals 180, or A equals 90 degrees. Because angle A equals angle B equals 90 degrees also. Paragraph proof. All right. Any questions? Shatif.